I'm James Linder, Innovation Scout for TVA, for our Transformative Innovation Group. This is TVA's second year with Incubate Energy Labs. This year, we chose to host LineVision as our partner to identify new innovative ways on how TVA is approaching the transmission system by using emerging technologies to enhance the grid. LineVision deployed a non-contact sensor to deliver situational awareness for the lines and collected data that they used to build comprehensive line health report for each line. No outages or live line work was needed to install LineVision's non-contact sensor technology. The sensors were mounted on the transmission structures themselves. All three sites completed in 2 days of field work. TVA selected spans on 3 different circuits, 3 project sites, where conductor health was a concern. We chose these lines from engineering perspectives based on, 1, various voltage levels. So these were from 500 kV to 161 kV. Different conductor types, bundling, single, double, triple, or bundled. Lines with and without mutual inductance from other parallel lines. Also, lines located on TVA property to minimize the impact on landowners based on the time and scope of the demonstration. Currently, TVA does not have a standard testing when failures happen on lines. Non-contact sensors fit the 4 of 7 pillars of grid modernization that TVA has. The first one is data analytics. Data-driven decision for operations. Treat data as an asset. Our next one is the field technology. Enable our transmission and field crews with new technology to make their jobs safer and more efficient and automated. The next one is grid visibility. Increasing real-time visibility and control for enhanced situational awareness and improved decision-making. And our last one is our asset management performance, maintaining a safe, reliable system to ensure assets are operating at the desired limits and meeting the system performance. So now I'm going to kick it over to Alex from LineVision to tell us about the technology.
Thanks very much, James. It's been great working with you and really proud to have been your second project as part of Incubate Energy. As James mentioned, our partnership with TVA was to explore LineVision's line health application, which tracks changes in conductor health over time. So our combined platform ingests both historic line data and real-time data using a scanning optical sensor with LiDAR to monitor your lines and report on damage from annealing, the effects of extreme weather, and elongation. And we use that information to generate reports for safe operating limits and the projected end of life of your conductors. And really, until now, utilities have needed to rely upon assumptions or destructive methods to understand the health of their lines. But LineVision's technology gives you a non-contact, non-invasive way to assess your conductor asset health, just like James mentioned. The results of the reports we deliver are objective. Everything is physics-based and follows IEEE and CGRADE standards. So whether we find extensive damage and accelerated end of life, or if everything is looking great and the lines are in good shape, either way, you're going to learn that as an output of our technology. And frankly, it's more important to know if your conductors are in bad shape so you can take steps to correct the problems before they become more expensive or more dangerous. But I guess objectivity aside for a moment, I'm really glad to report that the lines that we monitored for TVA that James mentioned are in really good shape. It's like when you're young and you go to the doctor for a physical, maybe there are a few areas of concern, but overall, you're really in good shape, you're healthy. And that's the case with TVA, which was great. So what did we learn from those 3 sites? First, importantly, we detected no damage from annealing at any of the 3 sites. Our historic thermal analysis showed no accelerated thermal aging. Our historic thermal analysis is important because that's what's going to point us to the need to look more carefully at existing lines. On one line, we detected under-tensioning compared to the post-creep design, and on another, we detected over-tensioning compared to the post-creep design, but both were well within NESC limits. We did find conductor elongation on one line, with the result that the designed sag limit would be reached at 190 degrees Fahrenheit, which was before the maximum operating temperature of 212 degrees Fahrenheit. So at the maximum operating temperature of 212 degrees Fahrenheit, the sag will equal 27.3 feet, which is 0.9 feet more than the post-creep sag limit of 26.4 feet, which represents an elongation of 3.4%. However, TVA is very careful, and their designed final sag values have a 3-foot safety buffer, and this increase in 0.9 feet still falls well within TVA's 3-foot margin of safety. But it goes the other way too. On one line, we observed that the design sag limit would not be reached at the corresponding maximum operating temperature. Instead, at the maximum operating temperature, the sag would equal 49.9 feet, which was half a foot less than the design sag limit, but safely within compliance. So overall, TVA is doing a great job, but the reality is nobody knows that you're an A student unless you run some tests. And that's why Line Health as an application is so important. So our goal at LineVision is to give you the tools to save time by having on-demand information about your conductor's health. We will save you money and resources by giving you the actionable information you need to prioritize maintenance and make business decisions about the management of your assets. We really enjoyed this project, and we very much look forward to meeting with you individually today. So thank you very much. And with that, I'm going to turn it over to Justin Bell, who is with EPRI, and going to talk to you about EPRI's role in this project. Justin.
Thanks, Alex, and thanks, James. So EPRI had a very unique role in this process in that this is really a demonstration project, and typically our role is more in a validation project. But what we did is try and modify what we would normally do for a validation study in this demonstration role. So LineVision deployed their unique sensors, their non-contact sensors into the field, and EPRI has also deployed precision weather stations to help gain some additional insight as to conditions that are occurring near the lines. And we can show both LineVision and TVA the methodology by which we would traditionally validate the performance of some of these tools and assure that the accuracy is within the limits that we're striving for. So as we begin and continue to collect data, we're going to be prepared in the future to say more definitively what the performance of some of these systems are and verify the value that TVA is receiving from this technology. One thing that we're seeing, and one thing that Alex has already mentioned, is in some cases there's room for additional capacity on these lines as identified by things like the SAG analysis. And the LineVision technology allows you to utilize that capacity by giving you some real-time intelligence of the line, which is something that's a growing industry need. And many utilities can relieve congestion and increase throughput or improve their utilization of renewable energy by utilizing a more time variable rating. And that's something that we've been able to bring into these discussions with James and the TVA team. And James, I'd like to turn it back to you for any thoughts and closing comments.
Yeah, thanks, Alex. Thanks, Justin. So as TVA continues to analyze the data from the Line Health report from our transmission line engineering design group, I want to give a brief update on about what we have discovered so far through this 12-week demonstration. The Asset Health report, we learned that this approach would help TVA observe the lines that are deteriorating rather than flying a particular line and giving us a point of time analysis. Using this sensor, we could watch and see how this line was loaded and the effects of weather it has during critical peak times when the system was loaded or over a greater amount of time versus the one point in time. Second, as TVA staff reviewed the Line Health report, we discovered something else that wasn't part of the scope. LineVision's capability of calculating and sensing the dynamic line ratings. This is particularly of interest from our operations staff, and we're looking to explore this further with LineVision in the future. Thank you for your time, and thank you for a great demo day.